hydrodynamics. Hydrodynamics, it is the branch of physics that related to fluids. So what's meant by fluid? Fluid, it's a type of matter where the molecules move freely as liquids and gases. So at the first, what are the characteristics of dynamic fluids? Number one, steady flow. Number two, turbulent flow. First, steady flow, it is the flow of the liquid in low speed such that its adjacent layers with respect to each other, like this is imagine this is the tube. In this tube, the liquid flow in low speed with layer adjacent respect to each other, not intersect. There is imagine lines known as streamline. What is the streamlines? They are imaginary lines that show the path of liquid at any part or fluid, during the steady flow inside the tube. Characteristics of the streamline as this figure. Number one, they are imaginary lines, they are not real. Number two, they don't intersect as they are parallel to each other. The tangent at any point along the streamline determine the direction of the instantaneous velocity of this point, of each particle on the liquid at this point. The number of streamline doesn't change as the area change. The streamline density at point change as the area change, which means that in the case of this tube, say there is 4 streamline. If the area increase, the streamline separate from each other to be lower density. If the area decrease, they will be close to each other with high density. Now, the other concept is flow rate. What's meant by the flow rate? It is the quantity of liquid flowing through a certain cross-sectional area of the tube in 1 second. Types of the flow rate. Number one, volume flow rate or QV. It is the volume of the fluid flowing through a certain area in 1 second. So it's unit cubic meter per second. So by applying this rule, Q volume or volume flow rate equal the quantity of liquid or volume of liquid divided by time. From the previous, you know that volume equal area multiplying length over time. But length over time is velocity, or distance over time known as velocity. So QV will be AV and the unit cubic meter per second. Second type of the flow rate is mass flow rate, which is known as QM. It means that the mass of liquid or fluid flowing through a certain area in 1 second. So QM equal mass over time, but from the previous you know that mass equal density rho multiplying volume. So it will be rho QV or rho AL over T. L over T is velocity, so it will be rho AV. The measuring unit is kilogram per second. Continuity equation. The velocity of liquid in a steady flow at any point is inversely proportional to the cross-sectional area of the tube. Look at this shape. This area, by increasing the area, the speed decrease. So in this area, small area, so the velocity is higher. Or when you'd like to make the liquid or fluid move faster, you have to decrease the area. Great. So the relation between velocity and area is inverse, as V1 over V2 equal A2 over A1, or A1 V1, if I make scissor, A1 V1 equal A2 V2, which is known as continuity equation. The base of continuity equation is that the relation between area and velocity is inverse relation. I can substitute area by the rule of area by r squared. So pi r2 squared over pi r1 squared, pi can be simplified with pi. So v1 over v2 equal r2 squared over r1 squared. If the branches are all equal, if I have to that divided in 2 or 3 branches, I can like that, like this shape, this area are equal, so Q1 equal N Q2 or A1 V1 in this case equal N number بتاعها times A2 V2. Note, blood flows at low speed through the blood capillaries. You know from biology that the biggest or largest artery is aorta, while the aorta will distribute the blood through blood tubes, arteries to all body parts. These arteries will be divided into smaller tubes known as blood capillaries. The total area of blood capillaries through the body is bigger, more bigger than aorta's area. So the velocity of blood through aorta is less than the velocity of blood in the blood capillaries. Okay? As this figure, because the total cross-section area of capillaries is greater than the artery velocity. Okay? Solve an example. Main artery, where the blood flows 0.08 meter per second, distributes the blood in 150 blood capillaries, each diameter 1/8 of the main artery. Find the velocity of the blood flow through each capillary. Okay, AV equal number of capillaries multiplying A1 V1. So the velocity 1 will be by dividing AV over number A1 will be area rule pi r square pi 8 r square V over pi r square 150 by calculating it will be yes 0.0434 meter per second. Okay, it's very slow. The other concept that related to this chapter is viscosity. What's meant by it? Look at this figure. Viscosity is the property by which is responsible for the resistance or friction between liquid layers and prevent sliding of layers above each other. The liquids around us, so there is liquids with low velocity like water, like alcohol, like acetone, like other chemicals, and other liquids with high viscosity like oil, honey, glycerine. It has higher viscosity. Viscosity here means resistance of the layer of liquid to be moved or friction, like this. The above layer has higher velocity than lowest layer. The viscosity force is directly proportional to area of the container of which is liquid found and velocity, and inverse to the thickness which is d. So I can remove the sign of proportion and put constant value which is known as viscosity coefficient. Okay. To get the viscosity coefficient in the side, it will be Fd over Av, which is measuring unit Newton second per meter square, or Pascal dot second, or kilogram meter -1 second -1, as its dimensional formula ml -1 t power -1. What's meant by viscosity coefficient? It is the tangential force acting on a unit area to produce a unit change in its velocity between two layers at the unit distance apart from each other. Viscosity coefficient